when we're doing an audit and we find a bug, there's usually significant time put into researching, validating, peer reviewing, and then putting it into a report that could be publicly available. And so we dot our I's and cross our T's. Is there a way you try to like kind of get ahead of that by saying, oh, if you found this bug, let us know. We'll validate if it's a real one or one we know about, and then skip it, don't do as much due diligence, and then move to basically have more opportunities to find the real bugs you would want to have them focusing on. Yuchen.
That's quite a long one. So far, can you hear me? Okay, cool. So far, we don't have processes in place for this. I think this is something where a healthy dialogue with our auditors is beneficial in many respects. So maintaining either like a Slack or a Telegram channel where you can ask quick questions and get these kinds of responses. I would say typically where we would reveal our withheld vulnerabilities is during the preliminary audit report before it goes to final. And then at that point, we would recommend that in the final report, they would say, this bug that we found was also injected.
Okay, there is another question there, and then there are a few. I will try to.
Yeah. Okay, you can go forward.
Yeah, can you hear me?
Oh.
Yeah, so my question also for Yuchen, of course, about the assumptions behind like the estimation model that you use. So I noticed that you yourself use the estimation model like for estimating bugs. And so how actually do you apply it? Do you have like a more complex model which takes into account the assumptions, or like do you just naively apply it and then softly weigh things based on your own knowledge of how things were implemented? Yeah.
Definitely much more of the latter. I would say we consider it more of like we're doing a Fermi estimate. So you take a bunch of different numbers and try to get a rough intuition for what's going on, the magnitude of what, the number of security issues you have or whatever.
Hello. Over here. To your right.
Oh, yes.
Yeah, so I think you're getting a lot of questions because you had really interesting work. I really like your guys' kind of data-driven approach to this. How effective are these security practices? But I guess for the injected bugs, you guys are looking at how do you know that these are reasonable bugs? Like for example, if you're injecting things that are small little typos or something like that, like a normal developer probably has some sort of linter turned on that's gonna they're not gonna be injecting these types of bugs, right? So how do you know that the bugs you're injecting are ones that actually would be happening in practice, or what's the ratio of bugs that you inject versus bugs that you find and just don't report, basically? So I'm kind of curious about your guys' decision making there.
Yeah, thanks for the question. I would say that the bugs that we're injecting are pretty much entirely a function of what our engineers are able to notice in normal code review. So there are these massive gaps that are very, very likely to happen, where if the particular reviewer of the day isn't well versed in things like reentrancy, then they may miss that there's a reentrancy bug being committed to the code base. And this is where I think a lot of the other frameworks, a lot of the other what Jörn was describing in the previous talk, where you have scoring and risk modeling, and an idea of how much scrutiny you need for what kinds of changes really comes into play.
Yeah, I'm from Auditing Forum. First, I want to say a question for Yuchen is that I love the approach. I really love the approach to injecting the bugs. My question is about the how to estimate the total one, because we know that not all the bugs are equal. In fact, most bugs are different. So how do you include in this factor that into your evaluation to say some of the bugs are really deep, or some of the bugs might have higher impact? I'm just curious about whether you have any plan to take those into account.
Right, and so this is actually one of the things where maybe we should admit that this was a clever idea at first, and we are slowly trying to figure out how to answer these questions more and more. So to expand on it a bit more, one thing that becomes an issue is you might say civil attacks on bugs, where you take one bug that affects a bunch of contracts. One bug that affects a lot of contracts and is essentially the same, and then there's now an incentive to say, oh, this is like 7 different bugs, so that the count goes up for this particular approach. And another issue is, as I alluded to before, you can miss entire categories, entire classes. And taking like the ecology kind of analogy, it's if you've got like a lake full of fish, and then you didn't realize that it's connected by a stream to an entire like gigantic lake. We don't have the answers to this. I think this is something that needs to be developed with the community.
Yeah. Hi. This is Stefan from Solidified Oak Security. So we are actually your auditor, and I'm only admitting this. So I'm only admitting this publicly because you said we did okay, which is good, I suppose. But my concern is also about the assumptions you draw from these injected bugs. And my question is, how do you decide how to, which bug to leave in? You said before these are bugs that you catch internally and you leave them in, which is good because it reduces sort of, sensible bugs, not artificial things that are that just waste auditors' time. So we are in favor of this, but how do you decide what to leave in? Because the concern there is you are only finding, if you do an internal audit, you are only leaving in bugs that are easily found in an audit. If you're leaving in things that are found in unit tests, you're sort of leaving in tests, but then you have to remove the test, and the auditor says, oh, you have a low test coverage. So how do you deal with deciding what to leave in and what is a good bug to inject?
Yeah, thanks for the question, and thanks again for being our auditor. It's good to meet you in person. I would say there definitely is this bias. There is a bias toward finding things that can be easily fixed with a single line, as opposed to things that would involve a massive re-architecture, because you can't just fix it with a single line. And this has actually come into play in one of our more recent releases, which is that one of our team members injected a bug, and then later on when we tried to fix it, we realized that this would involve entirely refactoring everything. It's not just a one-line change. And so there would be a bias against injecting bugs that are like this, because if it's something that would require a full architecture refactor, you try to catch it earlier. You try not to make this like a late stage gigantic change, and that's a problem. But I guess to flip it around, I would say our best use for this has been as we're developing this. I think early on we thought it would be a good kind of broad scale benchmark for all severity levels and difficulty levels in finding it. But now we're moving towards using this more as a medium hurdle to clear, to say, just a binary answer of are they doing a decent amount of basic diligence, rather than finding the most complex and most esoteric kind of bugs.
Hi, Jonathan from Chainalysis. A question for Nicolás. I sort of really interested in sort of the empirical side of governance, and how big are these problems of DNS, and have we tracked back to any actual loss of funds or anything on the empirical side? Has anyone done that type of analysis?
Can you hear me? We haven't been subject to this sort of incidents, thankfully, because we would have been ill-prepared and they would have been catastrophic. I don't know off the top of my head of any other protocol where this sort of malicious, where the attack was for making them verify incorrect information that I was talking about. But after looking at what our entire system looks like, and given the different safeguards that exist in place, and how signatures happen, and who the signers are, and how voting happens, and so on, I think at least in our case and cases similar like us, it is definitely the avenue with the most risk in terms of new things being introduced and those things being wrong. Yeah, but I don't know of any actual instance that has occurred this.
Nicolás, I had a question for you. I think your work is valuable. So one of the things that I had a question on was understanding that approval approach, right? So if you're going to have someone approve that, it's going to be internal to you, or is it going to be somebody that's attached to that wall that's trying to make the transaction?
Sorry, I couldn't hear the last part. Could you repeat?
So is that part...
So my question is whenever you're doing the transaction delay, right? So is that approval within the chain itself, or is that approval coming from the actual owner of the currency?
Oh, no. So if I get your question right, like the actual delay happens on chain.
Correct.
The actions exist, the action IDs exist on chain.
Okay.
And there's on chain requirements about what the minimum delay is for scheduling different actions.
Okay.
So it should be impossible, barring bugs, that an action is executed with a shorter delay. And when the action is scheduled, it is committed with all of the information, what contract is going to be called, what is the data, if there's ETH going to be sent, how much ETH is that, and all of that is locked in and cannot be changed in any way, except in canceling. But all of that happens. So I didn't talk about this, but like that being on chain, we hope it'll be that much harder to make it so, say, you fake, node providers and you provide fake blockchain data, right?
Correct.
As opposed to, a DNS of some random server on a cloud provider.
And how long is that delay?
It depends. We have a minimum delay for anything that is non-trivial of 5 days, which we think is a sensible duration for things to happen, someone to have time to look at them, and if there's an issue, discuss that, escalate, and then gather signers. We expect for each of those steps to take at least 1 day in an optimistic scenario. So we make it so no actions that are not trivial can happen within less than 5 days. It's quite tricky sometimes designing those systems because some actions that might not seem very important are actually important. For example, increasing the delay of an action is also a critical action because if you increase it to 2 years, then the action is now unusable.
Right.
But yeah, we have that minimum.
Okay, thank you.
Okay, we have the last question, and then we are done with session 2.
Hello. So my question is to Storm 0x about risk assessment and scoring. What was the process like for coming up with the scoring guidelines for each component, and how have you refined the process over time and ensured that it is accurate and useful?
Yeah, I guess like I mentioned, we had several like a season of incidents where we were just putting out fires and trying to figure out what went wrong and trying to start with postmortems and trying to analyze. And we quickly like converge into this dimensions. Okay, things that happen before the code goes to production. So we sort of those checklists of things that are sort of readiness for deployment for a production contract. We made those into dimensions, and then you can score them and be flexible about them to not like because you need to like I mentioned, we cannot afford a heavy upfront design, and usually all these things, formal verification, audit, things happen after the fact when the code is in production. So how do we score it? So the things that we control are internal procedures, and you see those as dimensions, whether it's code review, test coverage. We put a score in the test coverage, or is that 80, is that 90%? That lowers your score. If a strategy is wants to, hey, I want to allocate more funds into this. Okay, can you improve your test score, or can you get somebody else to peer review it at this point? And we're still ongoing adjustment. I don't think it's perfect by any means, but so far it has been proven. Like we saw the drawdown. Yearn was in several protocols during the whole Terra collapse and everything, and we didn't lose a cent. Some of this came out well enough for us, but for sure we can find better ways to improve it. And like I mentioned, hopefully this ideas can be generalized to other protocols.
I'm sorry.
There's a sort of black humor phrase in the avionics industry that goes that the guidelines have been written in blood. It's not that someone came up with those ideas, but rather they're the result of seeing issues and then going, how did this happen? How to make sure it doesn't ever happen again? You were talking about biases and the engineers' biases. We found that in the bugs that either auditors found or didn't show up in a bug bounty or whatever, there's often a trend. It's like, oh yeah, of course there's an issue in that part of the system, because we never really think much about that part of the system. So let's make sure that no longer happens, right? Let's make sure these types of issues are now more thoroughly thought of from the get-go. It's a lot of trial and error. And I guess hopefully errors don't go very, very bad. But
you can ask a question, but you are gonna get the answer off chain, I think, and offline.
It's real quick. I promise. The question is, how often do you cycle through auditors, or do you use the same 3 auditors like every time? And the second question is, do you use the same kind of bug program internally to try to incentivize engineers to actually trick other engineers to approve these bugs and then realize that they're just rubber stamping?
The answer is gonna I'm sorry, man. That's not my fault. Okay, that's it for session number 2. Thank you, everyone, and see you after lunch.